Check recording. All right, we are recording. So this is chapter 4 for quantitative reasoning for Philadelphia University. The chapter is managing money. This chapter, we're going to go over some very basics of finance, sort of a finance 101, if you will, quick take on that. We're going to go over some of the math that is used when financial institutions manage your money and ways that you can use simple equations to have a better understanding of that. There's 4 parts that I cover in the class in this chapter. This particular lecture will not go over an hour, and it will go kind of as far as it needs to go. So we may be covering more than one section depending on how it goes, but I don't want to go over an hour. So let's get into it. First thing we'll talk about is taking control of your finances. What does that mean? Well, in order to have a better understanding of your finance, better understanding of your money, better understanding of your wealth, you first of all need to know how much you have, right? Know your bank balance. If you know how much money you have, you know how much money you can spend. It's not only embarrassing, but also negatively affects your credit and is a bad look if you have your debit card rejected because you try to purchase something you can't afford. Or if you end up spending too much money that when you go to buy necessities, you can't have them. So knowing how much money you have is important. And nowadays, you have your bank's app on your phone. Look it up and check it. Know how much money you have. Know how much money you need to spend. Every week, every 2 weeks, you're probably going out there buying necessities, buying food, buying gas, paying for rent, paying utility bills, things of that nature. All that money is cyclical, and you can have an understanding of how much you need to spend each month, and you therefore have an understanding of how much you want to spend each month. Having that information handy, readily available, even if it's just in the back of your head. All right, rent $600 this month. I have $900 in the bank. I really shouldn't spend more than $200. Something like that is very crucial. Not buying an impulse is a big thing to learn when controlling your finances. Think first. Buy only if the purchase makes sense. Sure, that new ATV looks sweet, but you got to pay rent this week. Do you really want to go into debt, have to maybe throw something on a credit card that you maybe don't need all that badly? Something to think about. Make a budget. By make a budget, I mean combine parts 1 and 2. Know how much you have, know how much you need to spend, and that gives you how much slush money, how much cash you have on the side to buy other things that aren't necessarily in the necessities category. Let's take an example here. Cassidy has recently begun keeping her spending under better control, but she still can't fully pay off her credit card. She maintains an average monthly balance of about $1,100, and her card charges a 24% annual interest rate, which it bills at a rate of $2 a month. Sorry, 2% a month, not $2, 2% a month. How much is she spending on credit card interest? Okay, so if she maintains an average monthly balance of $1,100, that means her average monthly interest would be 2% of that $1,100. Since she's maintaining that as a balance, that includes both income and expenditures. That 2% billing rate is an expenditure. So what is 2% of 1,100? 2% is a percentage. So we don't use percentages in math, and except for those rare occurrences, we always use the decimal equivalent. 2% is 0.02. Times that by 1,100, you get $22. Multiply that by 12 because, as I said previously, the credit card company bills 2% at every month, and there's 12 months in a year, coming out to a total of $264, which means interest alone is costing Cassidy $264 a year. That's a not insignificant amount of money to some people. Something that maybe you should look at and say, okay, I'm keeping this balance level. It's costing me $264 for the privilege of the credit card company holding this debt. perhaps Cassidy should spend a bit more on the credit card, pay it off, so this $264 is less and less and less. So, basic understanding of how that works. Let's talk budget making process. First step of a budget making process, according to Pearson's, is to list all monthly income. How much you bringing in? You need to know how much you're bringing in from all varieties, from your job, from the investments you have. If you got a buddy paying you back $20 a month, throw that in there, right? Any income that you are getting. Know how much you're getting. Know how much you're spending. Determine your average monthly expenses. Tuition, books, vacations, for those of us lucky to do that. Insurance. Christmas is coming around. I need to increase my monthly budget because I need to buy holiday gifts, right? Know how much you're getting in. Know how much you're putting out. That allows you to determine your net monthly cash flow. How much you get paid minus how much you're paying. Whatever's left over is your net money. And then finally, once you know these two parameters and you've discovered the third, make adjustments as needed. Sometimes your income can't really be changed, but I'm pretty sure your expenses always can be. Perhaps you don't need to be buying the new textbook. You can find it used, right? Take that little bit of extra effort. Perhaps you don't need to buy as many gifts for your niece's birthday. Instead of buying her this real nice $100 toy, buy her a $10 toy. She's 6. She doesn't care, I promise. Here's an example about this subject. In addition to your monthly expenses, you have the following college expenses that you need to pay twice a year, 2 semesters, right? $3,500 for tuition each semester. That's a cheap college. $750 in student fees each semester, and $800 for textbooks each semester. How should you handle these expenses in computing your monthly budget? Well, we know each semester we need to pay $3,500 plus $750 plus $800. So the amount paid over the whole year would be that number times 2, or about $10,100. Divide that by 12, that means college is costing you about $840 a month, right? These large, seemingly abstract numbers can be divided into a nice month-to-month schedule so you know how much these things actually work. And yes, truth be told, most of us are having grants or loans for college. We don't pay it for it monthly. But you could turn this around to be really any topic and the idea would still stand. The average monthly college expense for tuition fees and textbooks comes less than $850. So you should put $850 per month into your expense list. Cool. Look at another one. Across all institutions, the average cost of a 3-credit college course is approximately $1,500. I can believe that. Suppose that between class time, commute time, and study time, the average class requires about 10 hours per week of your time. Again, I say it's kind of reasonable. Assuming that you could have had a job paying $10 per hour, what is the net cost of the class compared to working? Is this a worthwhile expense? So a practical application of this would be taking a community college class for some sort of certification. Is it worth taking that certification class as opposed to working set hours more? A typical college semester lasts about 14 weeks, as you know. So you lost, essentially, work wages for the time you spent in class, going to class, and studying, right? So if you spend about 10 hours a week for 14 weeks, not making $10 per hour, that means over the semester of college, you are $1,400 more poor than you would have been had you worked those extra 10 hours. And this is a question a lot of people actually have to ask themselves. I'm working at a restaurant as a waiter, let's say, or waitress. I'm going to take less hours so I can take these classes. Is it really worth it for me? How much did I lose? Can I afford to spend essentially $1,400 to get this $1,400 in lost income, not only in the price income for not only cost for the class, but also in lost income. Can I spend $1,400 to get this certification, take this class, whatever? So we find your total net cost of taking the class by adding this to the $1,500 that the class itself costs, resulting in a little less than $3,000. Is that worth it? Should I pay essentially $1,500 for the class and then $1,500 less income to get this? Well, in most cases, yes. The more educated you are, the more certifications or accreditations you have, usually the higher up the social ladder you climb. College graduates earn nearly $1 million more over their career than most high school graduates. And again, let's take a look at the math. This is a math class, remember? That math's super easy, right? It's just taking the question in its somewhat arbitrary, confusing word problem format and translated it into numbers and operators. So let's go over, excuse me, my cat's trying to eat some plants real quick. Come here, you. Yeah, good kitty. So, insurance costs. We talked about some basic math involving finances. Let's go over some words that I'm sure you've heard, but you probably don't know the definitions of. When you have insurance, most all of us will have usually health insurance at the very least, maybe car insurance, car insurance, motorcycle insurance, homeowners insurance, renter's insurance. I don't know if you knew that. Renter's insurance exists, and it's a very good thing. Insurance keywords. Premium. The premium is often the amount you pay to purchase the policy. That's what it is. The premium is how much you pay each month for the insurance. A deductible is the amount you personally responsible for before the insurance company pays anything. So you have a claim you file for your insurance. You have a deductible that you have to meet before insurance covers the rest. Very common in health insurance. You go to the emergency room, there's a deductible that needs to be covered by you before insurance will cover it. Usually the more your premium is, the less the deductible is. There's also a copay, which usually applies to health insurance and is the amount you pay each time you use a particular service that is covered by your insurance policy. Copays, for example, prescription drugs have copays usually. And the fun thing about insurance is the higher your premium, the more you're paying the insurance company per month, the less you pay in deductibles and copays per actual use of insurance. There's many different policies for a reason. It's good to actually take the time, go over policies, either with your insurance broker or on your own, and try to find what fits best for your current situation. If you think you're going to be using this particular insurance a lot, it's probably a good idea to pay a bit more per month in a premium in order to pay less for deductible and copay. Here's an example. Suppose you had an accident, end up in the ER, end up in the emergency room. You receive a $7,000 bill for your treatment. So I'm assuming they removed a sliver. That'd be my guess. Fortunately, you have health insurance, but your policy has a $1,000 annual deductible and a $250 copay for emergency room visits, and only pays 80% of the remaining balance after that. How much will you pay out of pocket for the emergency room visit, assuming that you haven't had any other medical expenses in the current year? So let me explain these numbers a bit better. $7,000 bill for your treatment. Again, they removed the sliver. They gave you a nice Band-Aid with maybe some Hello Kitty on it or something. Congratulations. $7,000 later, you don't have a sliver in your toe. The health insurance policy you have has a $1,000 annual deductible. At $1,000 annual deductible means at the start of whenever the insurance company deems their fiscal year, you have to pay $1,000 to them before they start covering expenses. So once you've met that $1,000, then beyond that, the insurance company will pay. $250 copay is whatever bill, whenever you go to the ER, you pay the first $250 of it regardless. And after all this, the insurance company only pays 8% of the bill. So the first two numbers, the $1,000 and $250, need to be removed, and then what's left over The insurance company pays 8%, you pay the remainder. So, and this here is in text of what I just discussed, right? So your bill is $7,000. You pay $1,250. You pay $1,000 deductible because you need to pay that before the insurance even thinks about looking at it, and you pay a $250 copay. Meaning, after your deductible and copay, you still owe $5,750. The insurance company will pay 80% of that. If the insurance company pays 80, you pay 20. So 20% of $5,750 is $1,150. Meaning you paid $1,000 for your deductible, $250 for your copay, and $1,150 of your 20% of your policy. So your $7,000 sliver removal from your toe actually cost you out of pocket $2,400, and the insurance company paid the rest, paid that $5,600 left, sorry, that $4,600 left over at the end. In this particular example, you've paid your deductible off, meaning the next time you get a sliver in your toe, that $1,000 will instead be part of the 80% that your insurance company pays. So, again, seemingly complicated. Take a second, as I've talked about plenty of times in this class. Take a second, slow down, figure out what numbers go where, turn the word problem into a math problem, and you'll find the math usually easy to solve. So, base financial goals on solid understanding. Find a way to make your budget allow for savings. Savings is very important. Understand how savings work and how to choose appropriate savings plans. We'll discuss savings plans in future sections. Understand the basic mathematics of loans. Usually when you go to the bank and get a loan, it kind of boils down to the loan officer gives you your option and you take it. But having a basic understanding of what you and the loan officer are discussing and all the weird words they use that are overly complicated can be quite beneficial to you, so you know what's actually happening with your money. Understand how taxes are computed and how they can affect your financial decisions. Again, taxes work kind of the same way loans work, where you just kind of do them. You don't really get to fudge things back and forth, but having a good, proper understanding of what you're doing can still be important. And if you end up being more and more wealthy, you can play with taxes more and more to your benefit. If you're not on a higher bracket of income, taxes just kind of taxes. Understand how the federal budget affects future personal finances. Again, this is something that is more akin to higher wage earners, but if you're taking a college class, you're going to be walking up that social ladder, walking up that financial ladder. So learning about watching CNBC, watching Fox News, watching C-SPAN, learning about how these things play and affect you can be very vital. Cool. Let's move on to 4B, the power of compounding. This is more math-based, as Unit 4A was a bit more thought-based. So, power of compounding. First of all, you need to know when I say principle, what do I mean? The principle in financial formulas is the balance upon which interest is paid. The principle is the amount of money you talk about. Simple interest is interest paid only on the original principal. It is not any interest added at later dates. Your simple interest affects your principal. When you start getting a student loan, simple interest and compound interest will annoy you. Compound interest paid both on original principal and on all interest that has been added to the original investment. So, your simple interest reduces your principal, reduces the actual amount of money that you originally talked about. Compound interest is a combination of simple interest and the interest that you pay the financial institution for the privilege of owing them money. It's a lot of times how banks make their money, how financial institutions, loan companies, I guess I'll say, it's how they make their money. Kind of. it's more complicated than that. This isn't a financial class. This is a chapter on finances in a broader class. So this stuff's, as with every class you take, you can always dive deeper into these topics. If this is of interest to you, I suggest you do some research on your own. Read a good book. Take a class in it, right? Stock savings bonds. You've probably heard of savings bonds. Well, banks almost always pay compound interest. Bonds usually pay simple interest. Suppose you invest $1,000 in a savings bond that pays simple interest of 10% per year. How much total interest will you receive in 5 years? If the bond paid compound interest, would you receive more or less than total interest? Explain yourself. So, simple interest means that the number associated with the interest only plays towards the principal amount. Meaning, 10% interest goes towards the $1,000. So what's $1,000 at 10%? $100, right? So this $1,000 bond pays you $100 every year for 5 years. So at the end of 5 years, this $1,000 bond has paid you $500 for taking it out. With compound interest, you would receive more than this because that 10% would go into the principal amount. So the second interest payment, for example, would be 10% of $1,100 or $110 payment. So the principal would be increasing with compound interest. Principal does not increase with simple interest. That's bonds. That's them paying you. We'll get into when you pay them. Somehow it's not always that smooth. Compound interest follows this scary, but in fact rather simple formula. A equals P times 1 plus APR in parentheses raised to the Y. In this example, P is your starting principal amount. P is the loan amount, for example. APR is not 3 separate letters. It's in fact one thing, and it's your annual percentage rate. APR stands for annual percentage rate. It's a rate. We've talked about rates in this class before, and you treat that rate as a decimal. Y is the number of years you're paying interest, and A is the accumulated balance, or how much you paid after Y years. You invest $100 into 2 accounts that each pay an interest rate of 10% per year. One pays simple, one pays compound. Create a table to show the growth of each over a 5-year period. Use the compound interest formula to verify the result in the table for the compound interest case. All right, so I should have been saying this before. I apologize. After you get the question, you should pause the video, attempt to do it, and then play the video again, find out if your math is correct. And if not, leave a comment down below, shoot me an email, talk to me in class, whatever you want to do. But it's good for you, since this is a math class, to attempt the math first and then to check it with my work. That being said, let's compare. Compare the growth of a $100 investment, 5 years, 10% simple and 10% compounding interest. Notice here, for the simple interest account, the interest paid will always be 10% because the simple interest only looks at principal. So after 5 years of simple interest payments, you've made $150 because you've made $10 a year for 5 years. Whereas compound interest, the first interest payment at the end of year 1 is the same, $110. However, whereas interest paid on year 2 in the simple is off of the 100, interest paid in year 2 in the compound is off the new balance, the 110. 10% of 110 is more money, right? So you made $1 more in the compound example than in the simple example. And this continues to grow and grow and grow and grow, such that at the end of year 5, the simple interest account paid you $100 is a new balance of $150. The compound interest account has a new balance of $161 and a nickel. So you've made $11.05 more with the compound interest account, than the simple interest account. And you can verify this using this equation we talked about before, where you plug the numbers in. Your APR is 10%, which is 0.1. 1 plus 0.1 is 1.1. Remember, you got to follow PEMDAS, the order of operations. Please excuse Madeira and Sally, parentheses, exponents, multiplication, division, addition, subtraction. So you do your math in the parentheses first, get 1.1, raise that to the fifth power to get 1.6105, and then multiply that into your principal to find out that at the end of 5 years, you should have $161.05, which is exactly what we calculated in steps previously. Show how quarterly compounding affects a $1,000 investment at 8% per year. Again, pause the video. Let's talk about it. As shown here, since we're compounding quarterly, that means you compound 4 times per year or every 3 months. The first quarter, you compound 2% interest because you do 8% per year 4 times in a year, so 2 plus 2 plus 2 plus 2 equals 8. Your first quarter, you make $20. Second quarter, you make $4.40. Third quarter, you have $61.21, and so on and so forth. The interest paid is increasing because the interest, the 2%, brings off of the new balance from the last quarter. Here's an example, here is an equation of a compound interest formula for interest paid n times per year. In this, you have a very similar looking equation, just we throw an n in it. N being the compounding periods per year. A quarterly compounding is 4 times a year, n would be 4. Monthly, n would be 12. Daily, n would be 365, what have you. The important part of this equation is to notice that n is periods per year and that y is years. Very important thing to note there. If you compound once a decade, n would be less than 1, right? But that's not really used for these sort of formulas, so forget that example. Let's talk monthly compounding at 3%. So you deposit $5,000 in a bank account that pays an APR of 3% and compounds interest monthly. The APR is 3%, interest is compounded monthly. So we're going to be, since we're not doing straight per year compounding, we need to use the equation we talked about before. As talked about in this class, it's good to write things down. It's good to write your variables down. APR is 3%, so APR equals 0.03, compounds monthly, and is 12. How much money will you have after 5 years? Compare this amount to the amount you have had if interest is only paid once per year. Cool. After 5 years, Y is 5. Pause the video, do the math yourself. Then we'll go through and we'll discuss the results. The equation looks confusing, but when you write down your variables, you find this an easy equation to solve. APR is 3%, N is 12. Do that division first, then add 1 to it. N was, again, 12. Y was 5, so your exponent needs to be solved first. 12 times 5 is 60. Raise 1.0025 to the 60th power and times it by your principal. And you find out that you compounded $808.08 of interest into your principal amount. So your new amount after 5 years is $5,808.08. Had this been only compounded every year, you would have less money, as shown down below there, $5,796.37. Granted, not a big step, right? It's like $12 and some change, someplace around there. But the more you compound, the more money you make. Interest paid once a year from the past 5 years using the formula, la-di-da. As I said before, the compounding every month made you $11.71 more, or cost you, depending if this is a loan or a bond or stock or whatever you did. The important note here as well, it may seem like if I'm compounding monthly, I'm going to make a lot more money. The truth of the matter is, since the amount of since the APR, the rate is the same, you're not really having a massive increase in money. It does increase because since you're compounding rather than simple, the balance the rate is applied to is whatever the new balance is after the compounding, meaning the balance goes up with each step. So the balance is going up per month. The amount the balance is going up is divided by the compounding amount. What I'm talking about here is that divide by 12 in the parentheses there. You're not doing 3% each month. You're doing 3% divided by 12 or 0.25% each month. That adds up to 3%, but it's not 3% a month. I hope that kind of makes sense. These numbers in the parentheses, the number in the parentheses for the compounded monthly is smaller, but the exponent is larger, which is how you get your profit. Let's talk APY, or annual percentage yield. You would probably know this as effective yield if you get into finances, and it is the actual percentage by which a balance increases in a year. It is equal to the APR if interest is compounded annually, but it is greater if interest is compounded more than once a year. So the APY, the effective yield, for the example, is the one where you compound monthly. The APR would be, the APR would be the one on the bottom here, which is compounded per year. So, said before, APR is your annual percentage rate. APY, you most commonly hear it as effective yield. It's your annual percentage yield. And usually your APY can be larger because most things you're going to do not compound annually. So you're probably going to be dealing with effective yield more than APR, but APR is used in the calculations. How different they can get. You will notice here, the more you compound, the larger the APY gets compared to the APR. You start out with an APR of 8%. And as we notice here, going from APR equals APY to compounding quarterly, we've jumped almost a quarter of a percentage point. However, the more we compound, the smaller the jump gets. Going from a quarter to a month gives us a 0.05 percentage jump, which is a lot smaller, but if you're dealing with large amounts of money, still noticeable. Compounding every day gives us a 0.03 percentage jump. So we're shrinking, the effective increase we're getting out of our compounding. So much so that we can compound, every second if we really want to. But the benefit of compounding every second versus compounding every day is, unless you're dealing with stupidly big numbers, basically negligible. And again, this is because the n in the equation is in the denominator, so the APR number itself is small, and at some point, the exponent's not going to help it that much more. Showed here this curve, at some point, your APR, your APY, your effective yield, levels out. And what you want to do is find a compoundings per year that gets you as close as you can to that annual yield without having the math just be stupid. At some point, you're not really getting a lot of benefit anymore, right? Continuously compounding interest. Continuously compounding interest happens, as said here, continuously. It is always being compounded. This is essentially run n to infinity would be the idea here. Except you can't run n to infinity. It don't work that way. So we use Euler's notation, E. This is a irrational number. It is a number that continues forever, similar to pi. And is equal, you say it's about equal to 2.71828. As it goes like continuously, it really doesn't matter past a few digits the majority of the time. This equation should look similar because, well, it's your percentage times some APR to give you a new amount. However, in this case, instead of what we've been doing previously with the dividing the 1 plus APR and stuff like that, since it's compounded continuously, Euler's notation, 2.71828, does that for us. Your APR is still shown as a decimal. You multiply it by the number of years and then raise Euler's notation to that power. E should be a fixed number on your calculator. It's similar to pi. If it's not, just use 2.71828. It'll give you the correct answer. Let's do an example of continuously compounding interest rate. You deposit $100 into an account with an APR of 8%, and you continuously compound it. How much do you have in that account after 10 years? Well, plug the numbers in, right? You have P of 100, APR is 0.08, Y is 10. Again, we're going to follow PEMDAS here, so we're going to do a parenthesis of the 0.08 times 10 to give us 0.8. Raise Euler's notation to 0.8 multiplied by 100. We find out that after 10 years, a $100 investment is now worth $222.55. Very simple math. Equation looks scary, but when you sit down, takes half a second to do it, equation ends up not being that bad. I think we'll call it good here. We'll start Unit 4C next session, give you some time to work on A and B. The math's going to get slightly more complicated here, but not really too bad. And truth be told, this is information that can benefit you the more time you invest into it. If you end up wanting to do things in the financial sector, this is highly important stuff. And hope you enjoy it. Please leave a comment in the video below if you want to have a discussion with me or your classmates. Have a good day. Take care.